Hello students, so this is your professor Dr. Sharma. In this video, I am going to discuss about very important concept in measurement. Basically, when you take data, you need to be familiar with the precision. You need to be familiar with the accuracy. What do you mean by precision? What do you mean by accuracy? We will take the real life example so that you can understand this concept fully here. And another thing I wanted to discuss in today's lecture is propagation of errors, because there are uncertainties due to the different factor, maybe the environmental factor, due to the human errors, due to the instrumental errors. Okay, so we have uncertainties, we have errors. So how these errors, when we talk about them, how they propagate, so we need to know about the propagation of error to develop the full concept about the uncertainties, errors, all about the measurements. Okay, you measure and then report the good data. So this kind of knowledge is very important. You need to know before you begin the real experiment. Okay, that's why we are learning this. So let me begin with the precision. So anybody can tell me what do you mean by precision? You may not answer your question in terms of physics or in terms of the science or in terms of the real laboratory measurement. Can you take a couple of minutes, couple of seconds to think about this? Precision, you know that, right? So yes, the precision is about consistency. Okay, it does not take care about the accuracy. It may be accurate or may not be accurate, but your result will be consistent. For example, if you are measuring the acceleration due to gravity in Fairmont, West Virginia here, right? Suppose you found the acceleration due to gravity here is 9.80 meter per second square, and you reported your group that you found the acceleration due to gravity here at Fairmont is at 9.8 meter per second square. Then again you do the same experiment. Now you found again 9.7, let's say 9.79 meter per second square. Another time you found again 9.80 meter per second square. Or another friend do the same experiment, use the same lab setup, same procedure, and that person also found 9.75 meter per second square, for example. It looks like 9.8, 9.79, 9.8, 9.75. If you repeat the same experiment, you get the same very close experimental value. They are consistent. So that means your results are precise. Your results are precise. Even those results are far from the correct value. Okay, they are pretty close to 9.81. They are correct. But even though if they are far from the correct value, your results are precise. Okay. So what do you mean by accuracy then? Okay, now you know that the accuracy here. So the accuracy refers to how close your measured value to the true value or accepted value. Okay, the acceleration due to gravity, for example, the acceleration due to gravity on Earth, a different place has different values, slightly vary. Okay, at top of the Mount Everest, at the sea level, at Fairmont, or maybe in the Rhode Island, or maybe the North Carolina Chapel Hill, wherever, slightly changes because acceleration due to gravity slightly changes with latitude, longitude, height, depth. You know that. You will know that during the mechanics course during this semester. But anyway, the average value is 9.81 meter per second square. This is the accepted value for the acceleration due to gravity. You do the experiment, you drop a ball, then you find the acceleration due to gravity, in your experiment. You found the value, suppose 9.2 meter per second square. That is little far away from 9.81, or you found 8 meter per second square. It is so much far than the true value. Your answer is not accurate. So if the accepted value is 9.81, your value should be 9.8, close to, right? 9.8 9.81, 9 point maybe, right, 82, whatever, it is pretty close to 9.81, then you can say that your answer would be, your data would be accurate. Okay, that is called the accuracy. We can take the simple example. We haven't discussed about the acceleration due to gravity. I give that example. It may be a little confusing for you. Let me give simple example. You are measuring the length of a table. Actually, I already measured as an instructor and as a professor. I already found that the actual value of your table is 2 meters. 2 meters length. Okay, and then I asked in your group, right? For example, Jackson measure it, or maybe Kelly measure it, or maybe you can say the Tom measure it, right? Sam measure it, and they found respectively, suppose Sam found it 2.01 meter, you can say that, right? Ram found it 1.99 meter, you can say that. Another your friend found a 2 meter. So your measure value is close to the accepted value, then your result is accurate. Okay, so you have to be very, very familiar in this concept regarding the precision and accuracy. So let me give you another simple example. So how many of you loves archery? Okay, I love archery, right? Shooting the arrow in archery game is always good, always I feel good. So suppose you have the archery, you are shooting the arrow, maybe this is the target. Suppose the target region is, let me use another color here. Here is the target region. You have the target region. Okay, this is the target region, and you have a bull's eye, that is called the arrow, right? You shoot the arrow and the target is here, your arrow should enter here. Okay, so let me give that example to explain about the accuracy, and let me discuss about accuracy and precision using that. So target is here, bull's eye, right? Suppose you shoot the arrow and your arrow exactly, you did 1 time, 2 time, 3 time, maybe 4 time, all the time, right? Your arrow hit exactly the target, bullseye. Then you can say that the target has been given and you shoot the arrow and arrow reaches exactly on target, exactly inside the target. So you can say that your measurement, your firing, your shooting of the arrow in archery is accurate and it is precise. It is precise and accurate. Okay, why accurate? Because it exactly hit inside the target. Why precise? All 4 times they are pretty close, they are consistent. Okay, same way you can, when you find the measurement, when you do the measurement and your results like that, you can say your measurement is precise and accurate. We wanted both precise and accurate, but sometimes. Let me take the same example here. Okay, let me take the same example here. So again, you have a target. You have a target again, bullseye. So you shoot the arrow. Now your arrow is look like you hit, right? You shoot 1 time, it reaches here, and 1 time it reaches here, another time it reaches here. So what you can say about this? Okay, so what is this here? Okay, it is not exactly reaches to the target here, not all 3 stages, not all 3 arrows, so it is not accurate. Okay, it is not reaching to the, even this arrow is pretty close to the target, but it is not reaching exactly to the target. Okay, it stops before the target here, and they are far from the target, so it is not accurate. Okay, not accurate. There is no accuracy in your shooting. Okay, what about the precision in this case? Can you tell me what about this precision here? So they are also not precise, so they are not consistent. One time here, then another region, so they are not consistent, so they are not accurate and not precise. If your data shows like that pattern, you can tell that the measurement is not accurate, your measurement is not precise. But there might be the other cases here. Okay, there might be the other cases here. Let me discuss about that. Okay, let's take the same example. Suppose again you have a target here. Okay, so you shoot the arrows, right? You shoot the arrows, and now at that time what you did is like that. So you hit the arrow, it reaches here, right? You shoot the arrow, it reaches here. In second time maybe it reaches here, another time it reaches like that here. So they are pretty far, little far away, but they every time they shoot, they exactly find the target here. What you can say that they are accurate because they reaches the target, because the accepted value, the measure value is consistent with the target here, the true value, accepted value, the measured value is equal to the close to the true value. So it is accurate. You can tell that it is accurate. But what about precision? Okay, they are not precise. Okay, it hits down, it hits up, it's the middle, so pattern is different. They are not consistent. It is not precise. Okay, there might be the another case, maybe like that way. Let me give you another example here. Suppose again you have a target here, bullseye, right? You shoot the arrow, and this time maybe you have the arrow reaches here. Suppose all three arrows remain like that way. What about the precision and accuracy in this case? So accuracy, no, because they do not hit the target, not bull's eye. They do not reach the bull's eye. So no accuracy. Here is a no accuracy at all. But in case of the precision, they are precise because they are consistent here. But precise. That's why in my lecture I talk about the precision. The precision does not mean your answer is accurate. No matter whether it is accurate or not, if your different trials are consistent, you can say that is precise. Okay, so we see here both accurate and precise. One accurate and another is not precise, right? One precise, one is not accurate. This situation you will deal when you take the measurement. Okay, I think I already spent the 13 minutes. If I include the propagation of error, the video will go beyond 30 minutes. So let me conclude this lecture video, pre-lecture video, to focus on precision and accuracy. And in next video, I will be discussing about the propagation of error. So I will see you in the next video.